Today is the penultimate session of this current bite-sized corrosion series. I indicated that we're drawing to the close of this series where we've been considering water and the impact of contamination on water. And for the past couple of sessions, we've been looking at some of the most contaminated waters that originates from acid mine drainage. And we've explored some of the challenges that provides, and yet how it is possible to transform that back into potable water. Now, today we're going to change our focus a little and turn our attention to one of the purest forms of water, and that is melted snow. Now, I haven't lost the plot completely, and I do know that I live in Africa, but the mountain kingdom of Lesotho really does receive heavy snowfalls, and it's that melted water that has been used as a supplementary supply to South Africa. And today I'm thrilled and delighted to welcome Lerato Kanetsi to the microphone. Lerato is a senior engineer with the Lesotho Highlands Hydropower Station with the Lesotho Highlands Development Agency, and she's graciously agreed to join us today. So a very warm welcome to you, Lerato.
Thank you very much, Vanessa. Thank you so much for having me. I'm quite honored.
Lerato, this series, although we've been focusing on some of the challenges of the contaminated water, very pure water can actually also be a challenge from a corrosion perspective, can't it?
Yes, that is correct. With pure water, it is very hungry for contaminants. It's unlike contaminated water, which is already saturated. The pure water can actually absorb a lot of minerals and a lot of substances and a lot of contaminants. So it is not as pure or as good as you'd like to think, as it can become very corrosive as well.
Oh, that's interesting. In fact, Danielle and I actually discussed that in the very first discussion of this series. Now, Lerato, back to you. Some of this pure mountain water, as I alluded to, is actually transferred to South Africa as part of our drinking water. And it would be really helpful for me and our viewers if you could possibly give us a little bit of an overview as to what the process is on your side of the mountain.
We collect the water at Katsi Dam. That is the dam that we have built in the Tawazaka district. And then from that dam, the water flows through what we call the transfer tunnel. So the transfer tunnel is from the Katsi Dam all the way to the Muela hydropower station. Okay. So we use the water to generate electricity, and then from there, we deliver the water to South Africa through what we call the delivery tunnel. So that tunnel runs from the hydropower station all the way to Clarence, Ash River outfall. And then from there, it joins the Ash River, and the Ash River flows all the way until it joins the Vaal River.
Wow. So the water that I'm drinking today in Johannesburg, South Africa, probably originated in your snowy mountains. That's wonderful. Now, in these tunnels that go through the mountain, your delivery tunnels, are they just hewn out of rock, or have they been treated in some form? I mean, how is it actually transported?
Okay, so our tunnels are bored in the mountains. So some portions of the tunnels are pure rock. Okay. And then we have sections that have been lined with concrete. Okay. And that is the majority of the tunnels. But then we have the places where the water becomes aggressive, if I may put it like that. So where we have a lot of cavitation. Those are areas such as areas where the tunnel crosses under the rivers. We call them the river crossings. Mm-hmm. So in such areas, we have lined the tunnel with steel. So we actually have steel linings in very aggressive areas.
And I'm hoping that because you've described these waters as aggressive, that steel is also protected with some form of corrosion protection.
Yes, all our steel linings are lined with epoxy coating.
Okay.
Yes.
And those were installed about, if I'm not mistaken, about 20 years ago. Have they lasted well, or are they starting to fail?
They are starting to fail because the coating material has come to the end of its life. So it has lasted a long time, to be fair, but we have seen that in some areas it's starting to fail, especially the wells.
Oh, that's interesting. Yes, I hadn't thought about the fact that The steel liner is not going to be this continuous steel. There's going to be welds along the way. Welds are a problem, it seems, wherever you use them, within a rock as a liner or in a conventional pipeline. Those are always, I suppose, the weakest joint. The steel liners that came in, I presume they were pre-coated prior to installation, and then the welds presumably were repaired on site during the installation of the original project?
Yes, you're quite correct. The steel lining comes in sections. So it was coated in the factory, but then the areas that are going to be welded to join the sections were left uncoated. So after welding, then on site, that is when we coated those areas.
And we've actually done a whole series on challenges with field joint coatings, and anytime you've got a weld and a field repair, that's always a difficulty. And I'm sure that working in the tunnels is an interesting place to work. Now, if you've had this coating in the tunnels for this period of time, have you just left it, or have you inspected it periodically just to see what sort of condition it's in?
We inspect the entire tunnel every 10 years. It's recommended that we inspect between 5 and 10 years. But in order for us not to stress the tunnel, it is more recommended for us to do it every 10 years. If we have an emergency or we have serious damage, we can push it to 5 years. So it has been done every 10 years, if I may put it like that. But the last inspection was in 2019. And then that is the time that we realized that the damage is very extreme and that we need to now recoat the steel linings. We need to blast and recoat the whole steel linings. So we had planned to do this outage, which is now 5 years later. So, like I explained, in a normal situation where it's just routine inspection, we do it every 10 years. But if we find that we need to act, we do it at the shortest time, it's 5 years to avoid straining the tunnel.
Well, I'm sure an outage, it's not as easy as closing the tap in my bathroom, because I'm sure the impact is quite enormous on so many sectors of numerous populations. So I imagine that this has been quite something in the planning. And you mentioned earlier that there's an epoxy lining on these steel liners. So if you're having a big shut now, are you going to be using the same epoxy, or have you changed your approach in terms of what coatings you could use? I mean, coatings have progressed phenomenally over the last 20 years.
That is true. Because we don't want to shut down frequently, as we are supplying water to South Africa, we are generating electricity. We want to minimize the time that we have shutdowns. So we have now decided to try glass fake epoxy. As you said, that the technology has changed. We believe now this will last even longer. That the epoxy we used lasted 20 years. So we believe that with this new technology, it will last even longer.
That's really quite encouraging to think about that. I had never thought of the fact that shutting down the tunnel was actually stressing on the structure itself. I can see it from the coating perspective and why you'd want to inspect it, but I'm now understanding with greater clarity how just turning off the water is actually a structural challenge for the components of the tunnel itself. So that's very interesting.
Yes, it can get very risky because, well, when we just shut off the water, if you just close the gates, that is not stressful to the tunnels. But if you actually dewater the tunnels, it becomes stressful because we need to ensure that the ventilation shafts are working properly. If they're not working properly, then when you dewater the tunnel, you cause a vacuum and then it can actually collapse. So it is quite strenuous to the tunnel. So that's why we don't want to do it very often.
Too frequently, yes. And I'm sure, just you're mentioning that, I'm sure there have been many challenges that you've had to consider in preparation for this shut. I'm sure that it's taken a long time in planning.
It has been a long plan. Like I've said, we don't want to shut off the water because so many people depend on it. The two countries depend on the water, South Africa for the water, Lesotho for the electricity. So we try not to affect the livelihood of people because even downstream, We have a lot of mini hydropower stations on South Africa side. We have the farmers who depend on this water for irrigation. So we try to minimize the impact we're going to cause. But also on the technical side, the tunnels can be quite humid. Yes, there's a high humidity in there and it's quite cold. So, as it is, the temperatures in the tunnel do not comply with the specification of most coatings. We have the substrate temperature quite low and the humidity quite high, as I've explained. So it is a challenge to work in such an environment. So we had to plan on how we're going to actually control the environment such that it could be conducive to coating. There's also a challenge of ventilation, as you can imagine, because we are going to blast the whole steel lining. So we have to control ventilation as well. It's not as easy as when it's done in the factory.
And you can't just rip it out and send it off to the factory to be coated. So everything is now in situ. And as we know from coating application, exactly what you said, you've got to consider your substrate temperature, the humidity of the environment, the ambient temperature. And that sounds like it's going to need a significant number of jerseys. Most coatings don't like working at those low temperatures and those high humidities. That's an interesting perspective, especially for us here in Southern Africa, where we think of the on-site applications of coatings to be under extreme sunny, high temperature experience. And that's not at all what the experience is going to be.
Yes, it's not at all going to be like that. But we have considered it, we have planned for it, and we have put measures to make sure that we get the environment right.
The other challenge, of course, with shutting the water, as you alluded to, is that it's going to impact so many people. In most project scenarios, time management is not usually the strongest point of a project. And I'm sure here we're working under quite significant time constraints because you don't want to stop the water for an undisclosed period of time. I'm sure you've got quite definite deadlines.
Yes, we have planned for the outage to last 6 months. So we have a lot of work on our hands in a very short period of time because we have to also leave room for dewatering the tunnel and actually filling the tunnel. So the actual work is actually going to be 4 months. So it's quite a tight schedule. And that's why we had to plan way in advance. We started planning in 2019 and we have done everything humanly possible to make sure that we have the right contractors in place, we have the right people on our side. We've even taken our people for training so that they can be able to do the quality control of the works. But we've also engaged a third party as a consultant to ensure that the work is done according to the standards and it's done on time. So we have a quality control consultant that we've also engaged. So we've tried, when I say everything humanly possible, to ensure that we get the water running within the given time.
Wow, that's impressive. And it's really encouraging to hear that such extensive planning and consideration has gone into the process, because I think very often, and now I exclude you as South Africans, I think very often we are not as thorough in our planning as perhaps we could be. And so it's really an indictment on us, and kudos to you for taking consideration of all those aspects. And I think it's also encouraging to hear you say that some of your staff have been trained, because I think that's also a benefit of big projects like this, although time-wise it's very short, relatively speaking, period of time, but it's encouraging to hear that your staff are being trained and upskilled, and in future can also use those skills on other aspects of their work. And that's also really wonderful to hear. It's really wholesome to hear that a project has gone into process with such a lot of support and consideration. And I'm sure that with everybody working together, the main outcome of this is that we want the steel to be protected so that this aggressive water, despite being very pure water, will not damage those steel liners. because the last thing we want for anybody and for either country is for the steel liners to suffer negative consequences, collapse, or be damaged. So it's lovely to hear that the corrosion protection considerations that we often talk about in these conversations are really being considered, implemented, and rolled out on this project. And I'm sure it's going to be a great success.
We are very positive that it's going to be a great success. We've put in a lot of energy and a lot of planning, so rest assured, we will have it done.
Yeah.
I just think that it's important to understand that as much as we want the plan to go according to the schedule within the given period and the budget, we also don't want to contaminate the water. So in the plan, we're not just looking at protecting the still line, we're also looking at protecting the end user. So that's why we selected the coating material that we did, because it's also recommended for potable water industry. Yes, so we have a lot of responsibility on our hands. It's not just to protect the infrastructure, it's also for the end user.
That's actually a very valid point, Lerato, and I hadn't really considered it. Although when we talk about water pipelines, we take cognizance of the fact that all the coatings need to be potable grade. Because these steel liners are so huge, and if I'm not mistaken, they're several meters in diameter, am I correct?
Yes, they are. Some areas we have 3.5 meters in diameter. That's the biggest diameter we have, 3.5.
And so when you're talking about these, you can lose sight of the fact that actually this is essentially just coating the inside of an enormous pipeline. And so the potable water requirements are as important as all of the others, because as you rightly say, you don't really want to kill off all of South Africa because of an incorrect coating. At least I hope that's not what you wish to do. So it's encouraging to hear that you've gone through such a thorough process to choose the right coating. And of course, your long-term goal is let's reduce the number of outages so that we don't sit without water for, as we're going to, for 6 months, or reduced water on our side. But that we're also just looking after the infrastructure by keeping it in operation for longer.
That is true. That is true. We don't want to open the tunnel anytime soon. We want the next time we open it to be in 10 years. Well, after such a big outage, of course, we might need to open it sooner just to check the quality of the work and if everything is in order. But from there on, we don't want to have any other reason to dewater except for inspection. During inspections, we usually take a shorter period of time, unlike when we have such a big work to do. So that's why the quality of the work is so important, so that we don't have to have a 6-month outage anytime soon.
And I think every South African is going, yay, because we don't want to be without water either. Oh, that's wonderful.
Yes. No.
I think it's been really interesting. I've learned a lot about the Lesotho Highlands system, and I hope that it's helped each of us to understand some of the intricacies of the upcoming shut and the importance of it, especially when we consider that the water from the Katsi Dam is so pure and yet so corrosive, and is absolutely critical in supplementary activity to the water here, particularly on the Highveld. Thank you so much. Have a great afternoon.